Okay, Kaushik, so you want today thermal snap, thermodynamic snap, and you are preparing for NMDC.
Yes, sir. Yes,
Okay.
sir. Material management, sir.
Material management in that NMDC.
Yes,
So
sir,
why you are
material
preparing this
management.
subject, thermodynamics?
Sir, because sir, it is usually seen that they ask some basic questions from that particular branch you belong to, sir. So I am preparing the basic subjects along with material management.
Okay. So what is thermodynamics, Kaushik? If I'll ask you, I will start with that. What is thermodynamics?
The thermodynamics is the science or the study that is concerned with the energy transformation that is occurring in a system and the energy interaction that occurs between the system and the surrounding. Yes, so this
So what is happening? What is happening, Kaushik, when energy interaction is taking place?
Sir, energy interaction is taking place, sir. Multiple number of things can happen. Now, if the energy interaction is taking place due to a temperature gradient being present, then that energy is termed as heat, sir. Now, this heat can actually contribute to the increase of the internal energy of the system or the thermodynamic matter. That can be in terms of potential energy, the kinetic energy, and this heat can also cause, or this energy can also cause external work to be done by the system or done on the system. It depends upon what is the condition. So the one form of energy gets converted with certain efficiency to another form of energy.
Just a second.
Yes, sir.
So, Kaushik, can you tell me the difference between isolated, insulated, and adiabatic system?
Sir, isolated system is that in that system there is no heat interaction and there is no mass interaction between the system and the surrounding. And this is an idealized case, sir. And in case of an insulated system, there is somewhat degree of heat interaction, but that heat interaction is very much negligible. And sir, adiabatic processes can be adiabatic system are those systems in which we can assume the heat interaction to be negligible, but there is this can be due to primarily one or two reasons. The heat interaction time that we are providing between the system and surrounding can be very slow, can be very low, which allows very low amount of energy to be interacted, and the heat transfer coefficient can be very low, or the area through which the heat interaction is occurring can be very low. So that can make the system to be assumed as adiabatic.
Can you give me example? One example of each. Can you give me one example of each, Kaushik?
So if you consider the universe, then that universe is an you can say isolated system, because there is no external influence on it, there is no external interaction. If we consider a vacuum insulated flask, that can be taken as an insulated case, and adiabatic is generally that processes that are very fast and heat interaction doesn't take place. For example, busting of a tire can be considered to be an adiabatic process for that given amount of time.
Okay, how we can assume that process is adiabatic? Means you are saying the process is occurring in a fast manner.
Sir, for example, so there is a finite rate of heat transfer that can be obtained, and for that given amount of finite rate of heat transfer, multiplied into that time will give us the amount of heat energy that is interacting. But the tire bursting process is a very fast process, and due to this reason, the amount of heat transfer that occurs is very negligible. So we can assume it to be an adiabatic process.
What about throttling, Kaushik? Throttling is also adiabatic? Throttling process.
So throttling is taken to be adiabatic process. That valve is taken to be completely insulated, or that nozzle is taken to be completely insulated. So it is assumed to be an adiabatic.
Like if it is insulated, why we are not mentioning insulated? We are saying it is adiabatic. There is no heat transfer.
Yes, sir.
In throttling also, we are assuming there is no heat transfer. But the process is not fast.
Yes, sir,
the process is very slow. The process is very slow in throttling. So how we can assume throttling process as an adiabatic process, Kaushik?
Sir, if the surrounding and if the temperature gradient between the system and the surrounding is negligible, then even though if the process is slow, there will be negligible amount of heat transfer that can take place. So we can assume it to be an adiabatic process. Or the area that we provide for the heat transfer to take place, so that is also quite negligible. So due to that very small area, we can assume that the throttling process is adiabatic.
Okay, that is a valid reason. Area is very less. So if area is very less, what you can say, the heat transfer will also be negligible.
Yes.
Then that will give us the base to assume that process as a adiabatic process. Fine.
Adiabatic process. Yes.
So that is a kind of, what you can say, the throttling when we carry out the system, which we assume that is a closed system, open system, or what? What type of system is a throttling device?
So when throttling device is considered, sir, it is an if you take it has to be analyzed using control volume approach. So it becomes an open device, sir, because mass is flowing in from a particular system boundary and massing flowing out from system boundary. So it is a open device.
So what is first law of thermodynamics for an open system?
Sir, can I write it, sir?
You can write, or you can tell
just,
any way which you feel comfortable. Kaushik?
Sir, I will be comfortable in writing it, sir.
Yes, go ahead.
If it is visible, sir. Sir, should I tell an entire equation?
Yes.
Sir, Q dot is equal to dm by dt into H2 minus
First
H1
tell me the assumption.
plus,
First tell me the assumption. It is an open system, but this equation you can write for every open system, or there is some particular type of open system for that you can write this equation. Kaushik. This equation is applicable to all type of open system.
So this is applicable to all type of open systems, sir. If the mass is not getting accumulated in it, then we can write this equation. There is a steady flow energy equation that I have written.
Yes. So you need to mention this is for open system steady flow devices. What you can say.
Yes, a
open system with the assumption steady flow. Okay. What do you mean by that, Kaushik? What do you mean by steady flow?
Sir, in case of a steady flow device or steady flow system, sir, the mass
device. Hello.
Yes, Kaushik, there is some internet problem at your end. Your voice is also breaking between. Your voice is not coming, Kaushik. Your voice is not coming. I think that it may be some charging problem of your headphone, Bluetooth device, because in the start also your voice was breaking. Please remove those headphones if you can. I'm not getting your voice, Kaushik. Okay, let's start.
So in case of a steady flow energy equation, we are assuming that mass being removed from that control volume. So the rate of change of mass within the control volume is 0 with respect to time.
Okay. So can you give me some more examples of some other what you can say steady flow devices?
Sir, for example, flow occurring through a pump or compressor, flow occurring through a turbine, and you can say the flow that is occurring through a throttling device. And so that is, for example, if we consider a given length of pipeline, the flow that is occurring through the two ends of the pipeline can be assumed to be a steady flow one. And so heat exchanger also we can consider to be having a steady flow device.
Actually, Kaushik, suppose that device is an open system, but it's the flow inside that device is not a steady flow. Then how you will write the energy balance? If there is a device,
yes, sir. Okay, yes, sir. It is not steady flow.
Yes, the flow is not steady flow. Then how you will write the energy balance and mass balance? For that?
Sir, that has to be written in sir variable flow energy equation, sir. I'm just sir. Okay, sir. I'm writing it and then I'm telling it to you. I have a camera issue here, sir.
Okay.
So the rate of change of mass within the control volume, that is dm by dt Cv is equal to dm1 divided by dt minus dm2 divided by dt, where dm1 divided by dt is the rate of flow of mass from the inlet, and where dm2 divided by dt is the rate of flow of mass from the outlet. Then for the energy part, we can write, sir, du divided by dt of control volume is equal to dm1 divided by dt into h1 plus v1 square divided by 2 plus gz1 minus then dm2 divided by dt into h2 plus v2 square divided by 2 plus gz2 plus q dot, that is the rate of heat addition, minus wcv, that is the rate of work being extracted from that work being done by that device.
Fine, Kaushik. Kaushik, can you tell me
Yes,
what
sir.
is first law of thermodynamics? What information we are getting from the first law?
So first law of thermodynamics is basically, sir, an extension of the principle of conservation of energy, sir. And it can be written in many formats. For a process and a closed system, it can be written as the heat that is added to the system is equivalent to the change of the internal energy plus the work done.
So I'm not asking you what is the mathematical equation for thermodynamics. I'm just asking you what is that, what understanding, what information we are getting from the first law of thermodynamics.
Sir, it is a quantitative law, sir. It states that we can convert.
What is your understanding? What is your understanding related to first law?
Sir, what I understand is basically it is equating the energy that is coming into the system to the energy that is going out of the system and what is accumulated in the system. So it is applying the conservation of energy that we learned in mechanics to the thermodynamic systems. And it doesn't tell us about the directional constraints that are present. So it means it, in case of first law, that equation will simply give us that the heat can be entirely converted to work. It will not contradict the first law.
Kaushik, what do you mean by degradation of energy? Like somewhere in thermodynamics, we studied about this.
Yes.
Actually, you can give the definition of second law also with this. In a real process, always there is a degradation of energy takes place. So what do you mean by that? Degradation.
Sir, degradation. So if we consider high grade energy, then that high grade energy can be converted completely into lower grade energy. But whenever we consider a lower grade energy such as heat, sir, if we need to convert it into high grade energy, the entire part of the heat is not provided to us through any device, sir. So the particular part which we lose is actually termed as the degradation of the energy. For example, if we get Q1, we have a maximum amount of work that can be obtained, and the rest amount will not be obtained by us. So that is the degradation of the energy.
Can we upgrade the quality of energy? Degradation to hoga real process mein, but can we upgrade it again? Can we upgrade it again?
Sir, upgradation is not possible, sir. I think so.
Why it is not possible, Kaushik?
So it is means it is there is irreversibility associated with any degradation, sir, and we cannot reverse that thing, sir. Once it is converted to any particular format, then further losses will be associated with converting it back into any higher format. So, for example, sir, if the kinetic energy of a body is converted into heat due to breaking, we cannot again think of recovering that heat and converting it back into the mechanical energy or the work, sir. Means at least complete conversion is not possible, sir. And because
I'm just asking you about the upgradation. I'm not saying ki upgrading the entire quantity. Obviously, if you are having some X amount of low grade energy, and if you want to upgrade it to high grade energy, the same X amount you cannot upgrade. That is fine.
Yes, sir.
But can you upgrade?
We can upgrade.
Heat? Yes. So upgradation is possible.
Yes, upgradation is possible. Yes.
But upgradation,
so for example,
same amount of with conservation of what you can say with the same amount of energy, that is not possible. Like suppose you are having 1000 kilojoule of heat, you want to upgrade it to high grade energy, means या work में upgrade करना चाह रहे हो, or you want to upgrade that 1000 heat, 1000 joule of energy, which is at some temperature, suppose 600 Kelvin, and you want to upgrade it to 900 Kelvin. So again, that is but for that amount of heat will decrease. So quantity will decrease. Fine. Okay, my last question is to you, Kaushik. What you learned, like can you conclude something, like what is your experience of studying this subject thermodynamics and how actually it is related to our daily life? What important conclusion you got while studying this particular subject? In 2-3 brief lines, you know, to tell.
Sir, actually, thermodynamics is pretty much relevant in any day-to-day activity, sir. And personally, I feel it gives us the directional constraints associated with converting into energy. Means as we engineers, sir, we use the power of the nature and harness it to our own application. So it tells us about the limitation, what amount of energy or what amount of work you can avail from the thermodynamics. Sir. Means there is a certain limitation. No one can exceed that thermodynamic limitation which is associated with any particular device, whether it being, sir, a coefficient of performance or the efficiency, thermal efficiency, if you consider. So it gives us a limitation that this is the limit, you cannot exceed that. We need to take us as close to the limit as possible. But without thermodynamics, sir, we would put some aimless goals. I mean, that goal is not actually achievable. So thermodynamics gives us the limitation of the goals, as per me, sir.
Fine. Okay. Okay, Kaushik, let me give you the feedback. So, Kaushik, I asked you about isolated, insulated, adiabatic, that you defined, answered. Thermodynamics, what you studied, energy interaction you mentioned. After that, I asked you about the why actually that you mentioned free expansion process is adiabatic. Valid reason you highlighted. Throttling process also you highlighted later on. What is the valid reason for throttling device? Steady flow energy equation, assumptions, all those things you highlighted. So whenever, like in any interview, any person is asking you what is first law of thermodynamics for a open system, closed system, so you need to mention the assumptions. Like
Yes.
when you start writing the equations, actually, you need to highlight the energy balance. Sir, first law of thermodynamics, sir, first law is actually a very simple law. It tells us about the law of conservation of energy. It tells us about the energy is conserved. So total energy is conserved in any process. We cannot create energy. Okay. So, sir, first law of thermodynamics for open system means, sir, energy in equal to energy out. Okay. So, sir, what type of energy a fluid can have at the inlet? It can have enthalpy, it can have kinetic energy, it can have energy, it can have potential energy. So the sum of all these energy at the inlet equal to sum of all these energies at the outlet. मैंने कुछ equation नहीं show किया, but I think the interview will be more satisfied with that. Are you getting my point? But if interview
Yes,
is
sir.
asking you what is first law of thermodynamics and you start writing the equation, so actually in interview those are the persons, those are not more interested in the equations. So you need to
Yes.
tell the significance. You need to explain. Sir, if I will consider a steady flow system, so the steady flow system, first law of thermodynamics will be different. For an unsteady flow open system, the first law of thermodynamics will be different than assumptions. So what is my suggestion? Mention the assumptions, then try to define in your own words what is that, what actually he is asking you. Okay. Then rare case you can move to the actions. Okay.
Okay, sir.
Okay. अगर वो आपसे पूछता है intentionally कि what is the equation, then you can mention. But otherwise, in other way also you can explain without highlighting the equation. So first law of thermodynamics you answered. I think first law में आपको ये जरूर बताना चाहिए कि sir we cannot create energy. That is the understanding which we are getting from the first law. We cannot create energy, sir. Creation of energy is impossible. But what we can do, only we can convert one form of energy into another form, sir, and that is the thing which we are utilizing. Whether it is a case of automobile, electric fan, air conditioner, we are converting one form of energy into another form. Okay, so that information we are getting from first law. So second law tells us even the input is required for the output, sir. The complete conversion of input into output is not possible. So always there will be some loss in energy. Always there will be some depletion of energy. So output will always be less than the input. 100% efficiency is impossible, sir. Okay, a process occurs in the increase in entropy of the universe. These are the many ways by which you can highlight the second law. Direction का बात करता है, ये सारी चीजें है ना. तो degradation you highlighted. So I got the that particular expression कि you know your knowledge is good, your way of expression is also good. But I just actually highlighted some of the point. I think you got that particular point. On what points you need to stress. So you need to be very specific, Kaushik. बहुत specific आपको answer करना पड़ेगा. And because they are not going to ask you much depth question of this particular subject. They will ask you basic questions only. First law, second law, energies, energy interaction, entropy, all those things. They're not going to ask you some numerical problems, like if there is some tank, some gas is there, you find out the entropy generation, like these type of things. Are you getting? These type of questions are more much what you can say asked in research organization, ISRO or DRDO, like things. So यहाँ पे basic things prepare करना है, but you need to be very specific with your answer. तो अभी मेरे को आपका ठीक लगा delivery. It is, I'm not saying it is not good. It is good. From my side, it is good, but you can further improve some of the parts. ठीक है, Kaushik?
Okay, sir.
Good luck and keep preparing.